So Faraday's great discovery was that changing magnetic fields can be thought of as sources of electric field. In this solenoid, when I'm changing the current, there's an electric field inside. If the current is no longer changing, it reaches a constant value, this electric field goes to zero because the result depended on di dt. And this was his great realization. Now, we also know, we looked at Lenz's law and asked what would happen if I took a conductor. So I'm going to try to draw a conductor here of radius r. So this is a conducting ring. What would happen in this conducting ring if I increase the magnetic field? Well, what we would expect is that if the flux upwards is increasing, then we should develop an induced flux downward, be induced, and that will oppose the change. Now, what type of current will give you that? Well, we'd expect to see a current I induced in that direction. Now let's draw that picture from the overhead view. So in the overhead view, we have B, di dt is increasing. Now I have a conducting ring of radius r. That's my ring. And if the flux is coming out of the plane of the figure and increasing, then what I expect is to get an induced, be induced, opposing that change. And that's generated by a current, I induced. And now we can see, why does a current flow in this conducting ring? And the reason is that there's an electric field. So when you change the magnetic field, there's an electric field that appears in this conducting ring, and that's the origin of the electromotive force, in this case our electromotive force, E dot ds, around that ring, and that's producing the induced current. And you can remember this, that the direction of the electric field is the same as the direction of the induced current. Here we argue the direction of the induced current by Lenz's law, and here we saw that the electric field was pointing in the same direction as the induced current. So that answers our question, what causes the current in the conducting ring when I change the magnetic field in the solenoid?